Okay, so today we continue with our next chapter, which is about chapter 8. Okay, chapter 8 is physical optics. So the only similarities between 7 and 8 is both of these are optics. Okay, but in terms of formula and everything, it's pretty much different things. Huh? So in this chapter, you guys will learn couples of things. So you guys will learn first, you guys will learn about Hygiene Principle, and then interference system, and then lastly is about diffraction. Okay, you might already learn some of it in your school, like a single slit dengan yang double slit. Both of them I think you already learn lah. But for today, we're gonna focus on this part. Okay, we discuss about Hygiene Principle. Okay, then we'll go through interference, the conditions and then we discuss about the principle of yang double slit, including the formula. Okay, so what is Hygiene Principle? Okay, according to Huygens, okay, Huygens actually is a mathematician, and Huygens actually described the motion of wave. It states that every point on a wave front can be considered as a source of secondary wavelet that spreads out in the forward direction at the speed of the wave. The new wave front is the envelopes of all the secondary wavelets. It is tangent to all of them. Okay, in other words, it's tangent to all of them. Okay, first of all, wavefront. So what is wavefront? Basically, wavefront, it's basically a wave lah. So wavefront can be in spherical wavefront, it can be plane wavefront, or it can be circular wavefront. For your syllabus, for you guys to be able to draw, basically it's about plane wavefront. So you can divide into two lah. Plane wavefront and circular. Spherical is a little bit hard to draw, so I don't think they will expect you guys to be able to draw lah. So kalau plane wavefront means that the shape is something like this. Okay, if you notice, I put like the edge over there, saya buat macam lengkung sedikit. So this part need to be straight line, but at the edge there, it's like curve a little bit. Okay, this one is for plane wavefront, and then circular wavefront, you have something that looks like this. Okay, that one is a circular wavefront. Oops. Okay, any questions so far about wavefront?
No, sir.
Okay, back to Hygiene Principle. Okay, dia kata Hygiene tu, I go back to Hygiene Principle. Every point on a wavefront can be considered as a secondary wavelet. Okay, so let's say if I draw a big wavefront here, so let's say it's a plane wavefront, Huygens principle state. So basically we want to describe how wave travels from one wave to another wave. So if you have a wavefront like this one, a plane wavefront, it says that every point on the wavefront, setiap satunya ada point, right, is a wavelet. Wavelet ni is source of secondary wave. So wavelet ni ibarat if you throw a rock inside a lake, then you can see the ripple or disturbance. Okay. So basically kalau saya baling, saya akan dapat macam ni lah, ripple like that. Okay. But it says that secondary wavelet ni dia akan move in forward direction. So basically it will produce a circular wavefront like that. Okay. Kan setiap satu ni akan produce banyak macam tu. Boleh bayangkan tak? Okay. And these new wavelets, ikut balik cakap ayat dia tadi.
Yes, sir.
Okay. Spreads out in the forward direction, velocity are the same, speed of the waves are the same. The new wavefront is the envelope of all the secondary wavelets ataupun tangent to all of them. So tangent to all of them is basically this one. Okay. So this is your new wavefront. So this one is old, that's new. Okay, and then the velocity of the wave will be constant. I will move in one direction. Dia bergerak satu direction, you know. So if I repeat the process, and then it will create another new wavefront, which is over there. Okay, so you can see that this one is actually spread out. Okay, it goes further away, it spreads out. Kenapa? Based on the Hygiene Principle just now, cara lukisan tu. So in exam, they expect you to be able to draw this one. You should be able to draw the wavefront. Okay, secara amnya macam ni. Let's say if you have obstacle. Okay, katakan ada obstacle in between the wave motion tu. Okay, let's say I divide into next one. So this is in different cases. Okay, let's say kita ada obstacle. And I want to describe the motion for wavefront. Initially, it's a plain wavefront like that, and then it passes through a obstacle. Okay, bila dia pass through the obstacle, so you only have this part, right? Okay, yang langgar tu dah tak ada lah part tu. Okay, and then dia kata setiap satunya adalah wavelet. Every point on this one adalah wavelet to a new front. So, kalau saya lukis kan, dia jadi macam tu. Okay, kalau saya lukis lah. Jadi saya tak lukis yang tu, which is kalau dalam exam kamu tak perlu lukis pun yang setiap satu wavelet tu. Just that you have to draw the next wavefront. So the next part you will get something like this. Okay. You can see that the wave always spread out. Dia sentiasa spread keluar tu. Dan jangan lupa kat ujung tu macam ada curve sedikit. Okay. Boleh tak? Let's understand this part?
Yes, sir.
Yes,
Okay.
sir.
And then obviously you have to draw properly lah. Katakanlah kamu berlanggar dekat slit pula. So if it's just a normal slit, means that the spacing between the two slits are big. Oops. Yo. Okay, let's say again this is an obstacle, tapi di dalam bentuk slit. So wavefront kamu initially is like this. Okay, bila dia kat tengah tu dia tinggal yang tu. Okay, bila dia keluar, dia akan jadi macam ni lah. It's still plain, just that dia terpotong sekejap, lepas tu dia macam tu. Okay, ini kalau dia punya slit tu besar. Okay, you have a very big slit. If the slit is too small, very small, which is comparable to the copy ini. If it is comparable to the wavelength, kecil lah maksud dia rapat. So like that. So wavefront tadi initially dia adalah plane. Okay, dan bila kat tengah tu dia tinggal satu je wavelet yang boleh terbentuk. Bayangkan dekat sini hanya boleh terbentuk satu wavelet je. So because it can only form one wavelet, so over here you basically will have a circular wavefront. Okay tak? You can understand? Any questions?
Yes, sir.
Okay, this one are some of the examples. If you have the wavefront which is passing through an obstacle. Okay, so by right we should be able to draw all this formation of wavefront. So you can go check dia punya apa tu nota kamu, and then you can compare lah. Okay, so that one is for the first part. This one is application for Hygiene Principle. Actually yang atas tadi lah, cara kita terangkan eigens tu. Okay, the next part is actually about constructive interference and destructive interference. So kita dah masuk the next subtopic lah, which is about interference. So there's two types of interference, constructive and destructive. I think by now you guys should be able to agak-agak lah apa maksud constructive dengan destructive tu. Okay, light wave ni actually considered as electromagnetic wave. Okay, we call that one as EMW. Consists of varying electric field and varying magnetic field. Okay, these two are perpendicular to each other. Okay, ini just dia punya pengetahuan untuk kamu. Tapi kamu dalam exam tak adalah ditanya benda-benda macam ni ya. Okay, ini yang penting. So this part is important. So dia kata interference is defined as the effect of interaction between two or more waves, overlaps or superpose at a point at a particular time from the source. Okay. For lights, the interference is occurred when two light waves meet. A bright or dark region will produce in accordance to principle of superposition. Okay, we keep adhering on this principle of superposition that kita discuss. Principle of superposition state that the resultant displacement at any point is the vector sum of the displacement due to the two light waves. Maksudnya hasil displacement adalah vector sum of displacement due to the two light waves. Kalau dua-dua tu dalam sama direction, so vector sum dia akan jadi constructive. Okay, ini yang dicakap kat bawah ni lah. Constructive interference, reinforcement of amplitudes. Destructive interference, cancellation of amplitudes. Maksudnya amplitude to cancel out each other. Okay, another important definition is monochromatic light, defined as a light of a single wavelength or frequency. So in simpler terms, monochromatic light ni biasanya ada satu color. Okay, dia produce by one color only lah. Sebab apa? Sebab wavelength dia adalah sama. So wavelength will determine the color of the light. So example, for red wavelength, maybe kamu punya region of wavelength tu around 700. Kalau blue around 400. So satu wavelength tu satu color. So monochromatic lights mean you have one color. Okay, one color of light. Okay, another important thing is about condition for permanent interference. So basically interference biasanya memang akan berlaku kalau as long as kamu ada pembelauan atau pertindihan wave, you can interference occurs. Tapi kalau kamu nak nampak effects of interference tu, which is permanent interference, condition number one is that the source must have the same wavelength of frequency. Condition number one dia adalah coherent. Condition number two adalah amplitude the same. Okay. Dan the third condition ni, yang distance between the coherent source small ni, biasanya kita tak discuss. Tapi adalah. Okay, so condition ni saya explain balik Ada dua. Number one, the light source must be coherent. Okay, lagi satu, amplitude roughly the same. Okay, coherent lights ada dua maksud. Coherent light ada dua condition jugalah. So yang pertama, coherent light ni kena lambda and frequency same. Okay, so maksudnya wave number 1, wavelength macam tu, wave number 2, wavelength macam tu juga. Okay, dia tak boleh macam tu. Like that, it's not a coherent source. So kalau tak coherent, you cannot see the interference pattern because you can expect lah. Satu tu macam ni, satu tu yang panjang-panjang. So you can't clearly see constructive dengan destructive interference tu. So pattern yang dark and bright fringe kamu tak nampak. Okay. And then another one, dia punya phase difference are constant. Okay, so basically kalau yang asal tu sentiasa lead by pi, dia sentiasa lead by pi lah. So dia constant, dia tak sekejap laju, sekejap slow, tak. Maksudnya dia constant. Okay, then only you can see a coherent light. Okay, itu syarat yang pertama untuk interference lah. The second tu, amplitude roughly the same. So kamu boleh bayangkan kalau kamu ada satu wave, amplitude macam tu, another wave, the amplitude is very big. So basically yang smaller ni, dia tak nampak pun effect dia yang dekat besar. So you can't see the superposition of wave punya pattern tu, tak nampak. Okay, so that's the idea. Okay, any question regarding the condition for interference?
No, sir.
Okay. So the next part is about path difference. Okay, path difference ni just have to know the theory. Okay, sometimes they might ask to calculate delta L, or they might ask to calculate lambda. They give you lambda and they ask you to calculate delta L, something like that lah. Okay, so to understand path difference ni, kamu kena faham pasal dua benda lah. Number one, you have in phase. Number two, you have anti phase. Okay, in phase dengan anti phase ni, dia ibarat starting point dia tu. Okay, starting point dia, wave dia, kalau in phase maksudnya dia bergerak together. So kalau kamu macam kawat kaki kan, so basically kalau kamu nak jalan tu, kamu jalan dengan kaki kanan, katakan kamu berdua, both of you will put your right feet first. Kaki kanan pertama, so sama-sama jalan lah, serentak. Okay, so kalau dia bermula serentak, dipanggil itu sebagai in phase. Asalnya dua-dua kaki kanan, lepas kaki kiri, kaki kanan, kaki kiri, kaki kanan, kaki kiri. Okay, so bila dia bergerak, so kalau dia bergerak sama jauh, okay, dia akan bertemu balik dekat satu point tu, dia akan jadi constructive interference. You can imagine lah. So dua ni bertemu, so dia akan create a superposition. Amplitude tu akan reinforce. So amplitude dia besar macam tu. Okay, ini dipanggil sebagai in phase constructive. Constructive in phase lah. In phase constructive interference. Okay, we can represent the formula dia sebagai delta L sama dengan M lambda. So M ni, kenapa dia M sahaja? Sebab dia bergerak sama jauh. Okay, ataupun perbezaan pergerakan dia tu by lambda. Okay, yang kedua pula, dia masih lagi gerak sama-sama, in phase. Okay, tapi bila dia nak bertemu, okay, katakanlah A dengan B ni, dia start dengan kaki kanan. Okay, tapi yang B ni, dia travel lebih sedikit. So bila dia bertemu dekat end point tu, maybe kaki kanan dan kaki kiri dia dah lari. Okay, in this case, kalau dia lari, so maksudnya satu kaki kanan, satu kaki kiri kan, so dia akan jadi destructive interference. Amplitude dia jadi 0. Okay, starting point dia adalah in phase. Tapi sebab dia travel more by half lambda, so dia jadi destructive. Okay, this one might not seem that significant, tapi kamu akan jumpa lagi yang ini. M dengan M plus half ni, you will see again, especially bila yang double slit. And then bila kamu jumpa dekat thin film, kamu ada in phase dengan anti phase, and then you have to determine lah, M dia M plus half ke M saja. Okay, case lain, dia adalah anti phase. So starting dia tu satu kaki kanan, satu kaki kiri. Macam tu lah dia jalan. So let's say dia jalan initially dah lari, kan, satu kaki kanan, satu kaki kiri, tapi dia jalan sama banyak, so eventually dia bertemu, dia lari lah. So you have a destructive antiphase. So the fact that dia starting dia tu berbeza kaki tadi, dia adalah antiphase. Bila dia jumpa, dia cancel out, dia panggil destructive. Okay, so M dia tak ada half, sebab apa? Dia bergerak sama jauh. Okay, dalam nota kamu sebenarnya dah ada lagi banyak gambar lah, so you can refer to that. Maybe you can get a clearer diagram, or maybe you get more confused, it's up to you lah. So yang this one, antiphase, maksudnya initially dia gerak satu kaki kanan, satu kaki kiri. Tapi maybe yang B tu, dia bergerak lebih sedikit, so bila dia berjumpa balik, kata sama pula pergerakan kaki dia tu. So in this case, dia antiphase, but then is adalah constructive. So amplitude dia reinforce gitu. Okay, so this one dia travel extra. So dia ada m plus half. Let's say kamu tak faham, you cannot imagine this part, at least kamu kena tahu dia punya m dengan m plus half tu. So untuk antiphase, m dengan m plus half dia tu terbalik daripada in phase. Okay, any question tak so far? You guys can follow? Ataupun adakah saya keseorangan di sini?
Sir,
Boleh,
Yes.
sir,
Boleh,
I tak faham
Ah.
antiphase constructive, sir.
Antiphase constructive yang bawah ni.
Oh, yes, sir.
Okay, so maksudnya, okay, initially, tadi kan, katakan kamu kawat kaki kan. So yang kamu ni jalan kaki kanan dulu. Kawan kamu ni pula, yang pair dengan kamu ni jalan kaki kiri dulu. So dia lari lah. Asalnya dia dipanggil antiphase. Sebab dia punya source tu, phase dia tak sama. Okay. But then, yang B ni, yang kamu-kamu ni, maybe dia jalan laju jauh sedikit. Dia travel more. So that's why ada half ni. Okay. So dia travel more, and then bila dia meet up balik, kaki tu dah tersama. Sama balik jumpa dia. So kamu boleh nampak lah ni sebenarnya construct. Dia tengah naik. Tadi. So bila dia berjumpa balik, konstruktif, dia jumpa dengan konstruktif, so dia jadi konstruktif lah. Maksimum dengan maksimum dia jadi konstruktif. Faham tak? So even though dia initially dia adalah antiphase, but then bila dia bertemu balik, dia jadi konstruktif.
Faham, sir.
Faham okay. So okay, kalau tak faham is okay, nanti kita cuba buat, kita cuba go through yang double slit, and then kita akan go through double thin film. So maybe after that, maybe kita boleh revisit lah, if you guys still don't understand. Okay, next part is yang double slit. So yang double slit ni actually adalah application untuk interference tu lah. So yang double slit is basically interference. So yang ni nama orang, double slit is the experiment. So yang double slit ni bila dia buat eksperimen long time ago, so at that time it's really hard to produce a monochromatic light. Tak senang nak produce monochromatic light macam ni. So it's really hard to produce dua lights yang ada sama frekuensi, sama wavelength and in phase. Susah. Sekarang ni dah ada lasers and everything, so senang lah. So at that time, the easiest way to produce two coherent light, so basically apa yang dia buat, dekat depan beam ni dia letak single slit, so dia akan produce circular wavefront. Okay, and then dia letak double slit. Okay, so double slit ni dia akan produce two coherent light. Tu dia punya advantage double slit tu. Cahaya yang keluar dekat sini dengan cahaya kat sini, frekuensi dia sama. Cahaya yang keluar dekat S1 dengan S2 kan, frekuensi dia sama, lambda dia sama, dia in phase. Sebab apa? Asalnya dia memang benda sama. So katakanlah asal dia tu dia warna hijau. Bila dia sampai kat sini dia warna hijau lah, takkan tiba-tiba jadi colour purple pula kan. So this still same light source. So you basically produce a monochromatic light, coherent light dengan same amplitude, so that you can see the interference pattern. So this is the interference pattern. Okay. So interference pattern over here, you can see that dekat tengah-tengah ni dipanggil sebagai central bright. Sebab apa nama dia central bright? Sebab dekat tengah ni memang tengah-tengah yang terang. Okay. Yang atas sini dipanggil first bright. Okay, bawah ni pun sama juga lah. So certain book dia pakai negatif macam ni kan, motor kamu ni pakai negatif, certain book dia tak pakai negatif tu. The negative here just to indicate yang di belah bawah lah. But then when you substitute the formula, you don't have to substitute negatif tu. So, biasanya saya tak letak pun negatif tu, saya ignore je. Okay, yang ni adalah M sama dengan 2, maksudnya second M ni maksudnya order tau, numbers of order. So numbers of second order ni, M dia sama dengan 2, and dia adalah second bright fringe. Okay, significance of M, numbers of M, actually this numbers of M is the one that you will substitute inside the formula. Bila kamu nak substitute dalam formula, you have to substitute numbers of order. So that's why it's very important. Okay, tapi yang ni kita cerita pasal bright. Kalau pasal dark pula, dark fringe, okay. Mana saya tulis saya pada ini. So for dark fringe, contohnya dekat sini kan. Ini, tak nampak kan? I try to find color that you can see. So here, dark fringe ni, M dia sama dengan, hopefully you can see lah, 0. Okay. Over here, M dia sama dengan 0. Okay. Walaupun dia M sama dengan 0, dia sebenarnya adalah first dark fringe. Okay. Yang ini adalah first dark fringe. And then bila M dia sama dengan 1, dia jadi second dark fringe. This one is very important because numbers of order untuk destructive interference for yang double slit, dia sentiasa kena, kalau dikasih numbers of fringe, you have to minus 1 untuk masuk dalam formula. Okay, kamu ada 3 main formula. This one, and this one. Yang pertama ni untuk constructive. Dan second ni untuk destructive. Okay, kalau kamu perasan ya, dekat sini dia M, dekat satu lagi M plus half. Constructive, kalau dia M, ini maksudnya dia adalah in phase punya interference. Destructive, M plus half, in phase interference. So maksudnya yang double slit ni dia adalah in phase interference. Sebab apa? Sebab macam saya cakap lah, dia memang satu source. So basically memang dia adalah in phase. So that's why dia punya formula is like this. Okay. And then kamu ada delta Y. Delta Y is basically the difference between two consecutive fringe. Okay, Y yang tadi, yang saya cerita Y tu, maksudnya mana saya nak contoh. Okay. So ini dia punya tengah-tengah tu kan. Okay. So jarak antara ini kita panggil sebagai YM. Kalau M dia sama dengan 2, so ini adalah Y2 lah. Okay, jarak daripada center tu. Kalau delta Y tu jarak antara 2 konsekutif. Contohnya from here to here, that one is delta Y. 2 consecutive bright fringe. 2 consecutive dark fringe yang berturut, itu adalah delta Y. Okay, so far you guys understand or not? Can you guys follow me?
Yes, sir.
Okay.
Yes, sir.
Jarak antara dua slit ni, we call this one as small d. Slit spacing. Okay. Jarak antara screen dengan double slit tu, we call this one as capital D. Okay, macam mana cara paling senang nak ingat? D besar tu biasanya nilai dia besar, D kecil tu biasanya nilai dia kecil. Okay, D kecil tu maybe dalam milimeter, D besar tu maybe dalam sentimeter. Nanti kamu tengok soalan, kita cubalah tengok satu soalan. Okay, and then yang delta Y ni sebenarnya katakanlah the next, between the next consecutive fringes kan. So dia maksudnya Y4, contohnya katakan Y4 tolak Y3. Okay, 4 ni yang seterusnya daripada 3 lah. So if I minus, then basically I will get M tu sama dengan 4 tolak 3. So sebab tu M dia tinggal 1. Kat sini 1 sebenarnya M. Okay, itu dia punya derivation lah, saya tak tunjuk pun. Simple je derivation. Okay, yang keynote here yang kamu kena ingat, yang M tu. Okay, M tu kalau yang untuk konstruktif tak ada masalah. Kalau untuk destruktif, if given number of fringes, okay, ni 2 minus 1 to subs into M. So if you want to substitute inside numbers of order M, dikasih numbers of fringes, you have to minus 1. Sebab apa? Sebab by definition tadi, bila dia dekat first dark fringe, dia punya M tu sebenarnya adalah 0. Bila dekat second dark fringe, M dia sebenarnya adalah 2. So kena sentiasa tolak 1. Okay, this is the only time kalau dikasih fringes, you have to minus 1. Ini sahaja dalam chapter ni. Okay, jangan pening balik. Satu ni je. Yang double slit, destructive interference. Okay, lagi satu yang student selalu confused, masa bila dia konstruktif, masa bila dia adalah destruktif. Okay, konstruktif ni as long as dia ada colour. So biasanya dia sebut bright lah. Tapi kadang-kadang dia tak sebut bright. Dia kata dia nampak pattern tu colour biru. So yang blue tu adalah constructive, any color. Okay, kalau kamu buat eksperimen, basically pattern ni dia akan nampak yang terang ni color. Kalau ini adalah red light, so basically this one akan jadi red, 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 red. Yang dark tu dia tak ada color. Okay. Mesti disebut dark lah. Kalau dia tak sebut dark, basically dia adalah no color. So kalau saya buat, kalau seorang dia cakap dia nampak fringe tu warna yellow, is it constructive ke destructive interference?
Constructive.
Constructive. Okay, good. So let's say the question tu dia kata dia nampak pattern tu color blue black. Constructive ke destructive?
Destructive.
Constructive. Masih lagi constructive. So any color it doesn't matter what color it is, dia masih lagi constructive interference. Kalau dia destructive, dia tak ada color langsung. Dia memang tak ada cahaya kat situ. Okay. So we call that one as dark lah. Tapi kita tengok background dia, kalau background putih, dia still warna putih lah. Tapi biasanya dalam exam dia tak confusekan kamu macam tu lah. Any color is a constructive interference. Kalau tak ada color, it is a destructive interference. Okay. Ini actually daripada learning outcome kamu punya dalam tutorial. Page berapa 70 kot saya tengok. Jadi kat sini dah ada kasih formula dia. Okay, sama macam kita tunjuk tadi lah. Yang important here, kalau kompresi dari M plus minus kan. So yang minus tu sebenarnya indicate bawah. Okay, yang penting dia dekat sini. Dark fringes, dia kata kalau first dark, numbers of order M dia sama dengan 0. Kalau dia second dark fringes, M dia you have to minus 1, which is equals to 1. Okay, sentiasa tolak 1. This is the important things. Okay. Ingat sampai bila. Okay, let's try to do one example. Okay, this one is a young double slit experiment. Separation of slit is 0.05 and the distance between the slits and the screen is 200 cm. The blue light is used, the distance between the center of the interference pattern with the first bright fringe is 0.13. Calculate the wavelength of the blue light used. So soalan pertama dia nak anda. Soalan kedua dia calculate the distance between the center of the interference pattern with the fourth dark fringe. Sekali yang kedua tu dia nak Y. Okay, question number 8 tu, first of all we have to take out the information. Okay, separation of seat 0.05 cm itu adalah apa?
D.
D besar, D kecil?
Kecil.
Yes, you can see that the values dia very small kan, 0.05 cm. I change to meter. Okay, so here if you want to solve, you have to use SI unit lah, so that you can get final answer in SI unit. Jangan slit tu dalam millimeter, distance dalam sentimeter, so dia dah lari lah, dia show unit dia sama. Okay, 200 cm tu unit quantity apa? Nilai apa? D juga kan? D besar, D kecil?
D besar.
Yes, D besar. Nilai dia pun besar. Okay. Dia kata when a blue light is used, the distance between the center of the interference pattern with the first bright fringe is 0.13. Okay, itu constructive ke destructive interference? Constructive, sebab keyword dia kat sini adalah bright. Dia memang sebut bright lah. So it's a constructive interference. Okay. And then kamu punya M dia, order dia sama dengan berapa? M dia, first bright fringe, M dia sama dengan berapa?
Satu
Yes, 1. Very good. Okay, very good. So constructive kamu biar je. Tak payah pening-pening, tak tahu apa. Dia destructive, dia kamu kena fikir je. Okay, so yang ini adalah Y1. Okay, kata the distance between the center of interference pattern itu adalah kamu punya Y. So basically apa yang dia cerita sekarang ni, kamu boleh bayangkan lah. Kamu ada, katakan ni dia tengah-tengah kat sini, right? So and then dia produce blue punya fringes. Okay. Walaupun saya lorek tapi ni sebenarnya ada yang bright. Okay, saya yang tak ada tu tak ada warna lah. Okay, so dia kata dekat sini Y1 dia tu nilai dia adalah 0.13. So itu maksud dia. Okay, so for interference yang double slit biasanya kan saya akan tulis formula untuk kedua-duanya. Y sama dengan M lambda D over D dengan Y sama dengan M plus half maklum. Lambda D over D. So formula mana saya nak pakai? Satu tu konstruktif. Belah kanan ke belah kiri?
Kiri.
Ya, sebab apa? Dia kata ini adalah konstruktif. So you use that formula. Substitute inside here. Therefore, Y1 sama dengan M sama dengan 1 lah. Lambda D over D. So Y1 tadi ada 0.13 times 10 negative 2. 1. Lambda dia adalah, kita nak cari distance screen 200 times 10 negative 2. Okay, kalau saya salah betulkan 0.05 times 10 negative 2. Lambda ni kamu dapat ni yang saya dapat lah, meter. Okay, kamu boleh tulis dalam nanometer kalau kamu nak, tapi kalau nak senang tak payah pening, biarkan je dalam meter. Sama tak dapat?
Sama sir.
Sama,
Sama sir.
sama dengan jawapan? So,
Oh, kejap.
sama. Ini soalan nombor 8, 3, 2, 5. Okay, sama So, betul lah tu. Okay. Okay, ada soalan tak?
No sir.
Okay, kita try tengok yang B tu. Calculate the distance between the center of the interference pattern with the fault dark fringe. So basically soalan dia kata nak fault dark fringe punya ni. So ini yang first dark fringe. Second dark fringe. Boleh bayangkan lah. Third. Ini lah yang fault atas utama. Okay, now question mana? Question mana kamu nak pakai? Kiri ke kanan?
Kanan.
Kanan, sebab dia kata fault dark fringe, so maksudnya dia adalah destructive interference. So we use destructive. So we use Ym sama dengan M plus half lambda D over D. Okay, now my question is M dia berapa? M dia sama dengan
3.
berapa? 3. Very good. Sebab apa dia kata fault dark fringe. So dark fringe yang keempat, tapi dia kita nak masuk dalam formula, M dia kena tolak 1. So 4 tolak 1 sama dengan 3. So Y3 is equals to 3 plus half X. Lambda tadi kita dah kira 3.25 times 10 negative 7. D besar dia 200. Tak mat 2 je lah. Over 0.05 times 10 negative 2. If you calculate, it becomes 3.5 times 3.25 negative 7 times 2. I got here is 4.55 times 10 negative 3. Okay, again, you can write in terms of mm. My advice is just leave it as it is. Tak payah pening-pening. Okay, any question?
No sir.
Okay, then the last part tu dia tanya pasal yang C. The space between the young double slit is then filled with water. Explain what will happen to the interference pattern on the screen. Okay, this one I want you guys to try to think about it. Okay, maybe tomorrow ataupun Friday jumpa. Okay, on Friday maybe we can discuss that one. Okay, saya nak tengok apa kau punya opinion. Okay, if there's no question, maybe we can stop here now, for now. That's it.